Hi, I'm Paul McDowell, Technical Services Manager for Asia Pacific for the CMON Company. Welcome to Module 7 of the CMON Network Infrastructure Design Program titled Asia Pacific Localized Standards and Trends. As you would have noticed in your previous modules, North America tends to follow the TIA standard when it comes to structured cabling. However, in most areas of the Asia-Pac region, we tend to follow ISO, the International Organization for Standardization. Based on that name, why the acronym ISO, you ask? Every language would have a different acronym for the organization, so the founders decided to give it the short form ISO, derived from the Greek word isos, meaning equal. Whatever country, whatever language, it is ISO. ISO 11801 is the overarching standard for cabling for the region. But countries like Australia and New Zealand have created AS NZS 11801, which is the same as ISO 11801. Japan has the JIS 5150, which is basically ISO 11801 in Japanese. Singapore and Southeast Asia follow a mixture of ISO 11801 and the TIA 568 cabling standard. The previous slide showed ASCA S008 and S009, which are Australian cabling standards. S008 applies to cabling product intended for connection to the customer side of the boundary of a telecommunications network. S009 applies to the installation and maintenance of said cabling product. There are many things to note from S009, such as separation between communications cabling and low voltage power shall be a minimum of 50 millimeters or a barrier. Separation from high voltage power cable shall be a minimum of 450 millimeters. Outside plant cables entering a building have become a contentious issue in the cabling industry. Because outside plant cable often contains flammable water blocking compound and their sheaths are often polyethylene, there are fire and toxic fume risks in having outside plant cables running inside a building. Section 16.1 of S009 states that customer cable installed within a building should meet Clause 5.6.4 of S008. But other cable may be installed in this situation if it is required for compliance with this standard. Note 1 states, and I quote, "There is no requirement in this standard to change the cable type where an underground or aerial cable enters a building. However, any cable used within the building past the first cable connection point should meet Clause 5.6.4 of S008. My suggestion is that if that first connection is not really close to where you enter the building, you should be checking with a building inspector or a fire inspector before running a cable any distance which puts people and/or the building at risk." ISO 11801 states that the minimum class or category of cable installed in a commercial building should be Cat 6 or Class E. One of the main differences between these cables is the maximum bandwidth you can run on them. The max bandwidth for Category 6 is Gigabit Ethernet, but on Category 6A, you can run up to 10 Gigabit Ethernet. Typically, Cat 6A conductors are bigger than Cat 6, which is better for remote powering. Here are a few of the main reasons as to why we recommend shielded cable versus unshielded. Wi-Fi, AV, DAS, which stands for Distributed Antenna Systems, PoE, which stands for Power over Ethernet, are all technologies that perform best with shielded cable. Shielded cables offer better protection from noise generated by devices such as motors, transformers, lighting, all things that you'll find in a ceiling environment where cables run. When referring to heat dissipation, meaning the transfer of heat to the surrounding environment, shielded cables have better heat dissipation than UTP cables. For example, when a data cable heats up because it is running power over Ethernet, the metal shield has a higher conductivity to dissipate heat over jacketing materials. When that DC current caused by PoE runs through a UTP cable, there is twice the temperature rise than that of a shielded cable. When it comes to cabling for audiovisual systems, CMON always recommends, at a minimum, Category 6A shielded cable. A couple of applications used to transmit AV signals are HD-Base-T, which is a standard for the transmission of ultra-high definition video and audio Ethernet and control signals, and SDVoE, software-defined video over Ethernet, which uses Ethernet switches to push these signals. For both of these applications to support 4K high-def video, the bandwidth required is 10 gig. 4K over Cat5e or Cat6 is limited to 70 meters or less. This is why companies like Extron and Crestron recommend Cat6a shielded or 7a shielded cable for their ultra-high definition video systems. Power over HD-Base-T expands what HD-Base-T offers and adds the ability to deliver 100 watts of power. When you are pushing that much power, you need the ability to handle heat rise, which 6A shielded cables allow you to do. Let's look at the construction of some of these shielded cables available in the market today. FUTP, UFTP, SFTP, and FFTP. Well, they all sound the same, but it's a bit confusing, so let's break it down. FUTP, which is what we have been primarily talking about today, stands for foiled, unshielded twisted pair. Under the sheath, this cable has a metallic foil around all the pairs. UFTP stands for unshielded, foiled, twisted pair, which means under the sheath there is no overall foil around the pairs, but each pair has individual foil around them. FFTP stands for foiled, twisted pair, which means under the sheath there is an overall metallic foil around all the pairs, and those pairs are individually foiled themselves. Then there is SFTP, which stands for shielded, foiled, twisted pair. Under the sheath there is an overall metal braid around the pairs, and each individual pair has a foil around them. Cat7a cables are typically SFTP or FFTP. Let's do a little comparison of UFTP and FUTP. We don't see much UFTP cable in the Australian market compared to FUTP. It is less expensive to make, but that's because it uses older Cat5e technology and has similar twist rates to Cat5e. UFTP is tedious and harder to work with compared to FUTP because you have to strip each individual pair. When you can terminate faster, you make up for the higher cost of the cable and labor. FUTP has been in the APAC region for over 20 years and is promoted by Tier 1 manufacturers, and it's always in stock. PowerGuard is a system of innovative designs that support the delivery of safe, stable, consistent, and constant remote power to devices on the network. These designs include cable that can operate at 75 degrees, connectors with crowned contacts that prevent erosion due to arcing when disconnecting power under load, modular plug terminated links, which is CMON's famous Z-plug field terminatable RJ45, and advanced patch cords that operate at 75 degrees with the ability to lock the patch cords at the port. This graph shows derating requirements for CMON's Cat6a and 7a cables compared to industry standard 6a UTP and 6a shielded. But first, let's talk about derating. Heat is the main reason why cables need to be derated. As current passes through the cable, heat is produced as a result of the electrical resistance of the wire. Multiple circuits running in close proximity can further increase the temperature of the conductors as a result of electromagnetic effects and physical proximity effects. When cables are arranged close to each other, cables have limited ability to dissipate heat and reach a hotter operating temperature. Linear resistance, the resistance of the cable per meter, is very small, but over a long cable run, it is cumulative and results in voltage drop. As the cable temperature rises, the linear resistance also rises, resulting in increased voltage drop and reduced system output. In our graph, we show how many meters a cable run must be shortened to accommodate a rise in ambient temperature, in this case at 60 degrees Celsius. An industry standard, Cat6a UTP, must be derated by 18 meters. An industry standard 6A shielded must be derated by 7 meters. But the CMON 6A shielded need only be derated by 3 meters, and the CMON 7A cable doesn't need to be derated at all. Cable labeling and administration does form part of ISO 11801 under ISO IEC 14763-2-1. There is also a TIA standard that can be helpful, which is the TIA 606C. Correct labeling and record keeping is a critical part of any cabling system. As we show here, there is more than just cable that should be identified. Cabling subsystems, of course, but also their pathways. The bonding and grounding system, the spaces in the system like the telecommunications room or the entrance facility, fire stopping if it's been done, and also remote power. The standards are there to help and recommend how to record the necessary information in a structured cabling system. Labeling can be very proprietary, so installers and consultants need to work with the end user to ensure they understand what their client wants. Typically, identifying the building, the floor, the room, the cabinet, the patch panel, and the patch panel outlet number are all required. These days, cabling system administration needs to be stored electronically and labels are electronically generated. There are specialized software packages in the market that do this, and industry-accepted drawing software like AutoCAD and Visio are quite common. Cable management is always tricky because it takes up space. And in any construction project, space is always at a premium. Cabling installers and designers always want bigger cable trays, bigger conduits, a wider rack, a taller rack, a deeper rack, and wider vertical cable management in the rack. Having all these luxuries make it easier to do a proper cabling installation because bend radii can be adhered to, because there's more room to store cable slack, because there's more room to do an aesthetically pleasing job. In this graphic, we show the recommended number of cables in a bundle and how they should be installed. Bundles to a maximum of 24 cables should be spaced in the tray in order to provide airflow through the tray. These bundles should be tied every 3 meters using Velcro. Nylon ties are allowed as long as they are not cinched too tight where they alter the geometric shape of the cable. Please note that in a lot of specifications, the use of nylon cable ties is not allowed, so please be aware and please refer to the specification. ISO IEC 14763-2 also called AS NZS 14763-2 2019, deals with the installation and planning of customer premises cabling. One of the latest additions to this standard has to do with remote power and how cabling is to be installed to be able to meet the requirements of remote power supply running over 4-pair cabling. For balanced cabling, in accordance with the ISO IEC 11801 series, remote powering equipment shall not supply more than 500 milliamps per conductor, and the installations shall be designed and designated in one of the following categories. Category RP1, attachment of the remote powering equipment at a distributor is controlled such that the average current for all conductors served by the distributor is not greater than 212 milliamps. For category RP2, attachment of the remote powering equipment at a distributor is controlled such that the average current for all conductors served by the distributor is restricted to a specified value between 212 milliamps and 500 milliamps. For category RP3, attachment of the remote powering equipment at a distributor is unrestricted, subject to the limit of less than 500 milliamps. In terms of planning and installation practices, the following apply. For RP1, you avoid planning and installation practices, but you do require documentation and administrative controls both during the attachment of remote powering equipment and any subsequent extensions of the cabling. For RP2, installations require planning and installation practices, along with documentation and administrative controls, both during the attachment of remote powering equipment and any subsequent extensions of the cabling. For RP3, installations require planning and installation practices, along with documentation and administrative controls during subsequent extensions of the cabling. Unmating a jack under load or unplugging the jack while power is running through the cable can cause arcing. Arcing is flow of electrical current through air, meaning electricity jumps from one type of connection to another, as in from copper to air back to copper. Siemens jacks with PowerGuard technology feature a patented crown jack contact shape that places arcing damage to both the plug and jack contacts away from the final mated position, allowing you to connect and disconnect to the latest remote powering applications with zero risk. The main thing to understand when calculating the number of cables that can fit into a cable tray and percentages of fill is that the normal calculations for area need to be modified. If you take the area of a cable tray, which is the area of a rectangle, and divide it by the area of the cross-section of a cable, which is the area of a circle, you will get a number that twice fills the cable tray. Because cables are round, there will be spaces between cables if they are loose laid or bundled. The accepted industry calculation for that space between cables is 50%. So when you divide the area of the tray by the area of the cable, you need to take that number and divide it by 2 to get a number that fills the tray to the top. At this point, you can now multiply by the percentage of fill that you have been asked for in the specification or standard. If it's 50%, multiply by 0.5. If it's 40%, multiply by 0.4, and so on. There are many factors involved in selecting the right type of fiber for your cabling project. We will go through the basics of type of fiber and cable construction. Typically, tight buffered fiber is used indoors and loose tube fiber is used for outside. As we stated in a previous slide, to avoid having to transition from an outdoor cable to an indoor cable, you can use loose tube indoor-outdoor fiber, which has a low smoke zero halogen jacket that is rated for indoor use. In Australia, it is common to have a requirement that fiber be rodent-proof and termite-proof. To be rodent-proof, the cable needs armoring, whether it is metallic or GRP in construction. To be termite-proof, the cable needs a layer of nylon. In cases where you are adding to an existing cable plant, you will want to match existing fiber if possible. Sometimes, like in the case of OM1 multimode, you will upgrade to OM3 or OM4. In the case of a brand new installation, you would use a minimum of OM4, but you must be aware of distance limitations on multimode fiber. Single mode can eliminate distance and bandwidth issues in many instances. Always consider the active equipment manufacturer's requirements. Color coding cables is something that has been going on for decades, even centuries. Conductor colors or fiber core colors are very important for terminating cables in the field. What we are talking about in this slide are colors in the LAN and sheath colors of copper and fiber. Copper cable sheaths can be any color, but sometimes the color indicates a service or a type of sheath. For example, Simon and other manufacturers have adopted violet as the color for a low smoke, zero halogen sheath. A red patch cord used to indicate that the cable had reverse pairs inside. Security contractors are using different colored sheaths to easily identify and differentiate their system. CMON can make copper sheaths in any color. When it comes to fiber, cable sheath colors are a bit more standardized. An orange sheath tells you the fiber is OM1 or OM2. An aqua sheath indicates OM3 or OM4. However, Europe seems to be adopting Erica Violet as the color for OM4. OM5 has a lime green sheath. For single mode fiber, the sheath is yellow when it is an indoor fiber. When it comes to outside plant, you usually find the cable is black, so you need to check the markings on the cable. If you find a blue outdoor fiber cable, listen closely to the next slide. As mentioned on the previous slide, a blue sheath on an outside plant fiber cable is quite common. The blue sheath indicates that this is a nylon-coated cable to prevent termite destruction. Now getting back to copper, in Asia Pac, you will typically find a PVC sheath jacket or a low smoke zero halogen sheath jacket used for indoor copper and fiber cable. These cable jacket types comply with ASCA S008. Low smoke zero halogen is the preferred type, as a PVC cable has a jacket that gives off heavy black smoke, hydrochloric acid, and other toxic gases when it burns. Low smoke zero halogen cable has a flame resistant jacket that doesn't emit toxic flames even if it burns. Green Star is an internationally recognized Australian sustainability rating and certification system. Green Star is helping to improve environmental efficiencies in our buildings while also boosting productivity, creating jobs, and improving the health and well-being of our communities. To save yourself any hassle qualifying your cable for Green Star, use low smoke zero halogen inside the building. Do I use an interconnect termination system or a cross-connect termination system in the telecommunications room? Take a moment on this slide to read the definitions, and then we will look at a graphic that shows the basic differences between interconnect and cross-connect. That's enough time, so we will move on to the next slide and differentiate. Looking at this visual, we have network equipment for both options. In a cross-connect design, the switch ports are replicated onto an equipment patch panel and patching is carried out between the equipment patch panel and the distribution patch panel. We recommend that the switch links between the active equipment and the active patch panel be solid core cable, as stranded cable can have length limitations or the equipment patch panel terminations may not accept stranded conductors. The benefit of this design is that the expensive active equipment can be mounted in a separate secure cabinet away from the passive patch zone, thus preventing any tampering with the active equipment. The drawbacks are that this design requires more rack space, more cabling components, and more labor required for the installation, all of which adds up to higher costs. In an interconnect design, patching is done directly between the active equipment and the distribution patch panel. This design is quicker, easier, and cheaper to deploy than a cross-connect design and requires less rack space. It is, however, less secure, as patching technicians must have access to both the active equipment and passive patch zone. When we think of zone cabling, we tend to think of an open office scenario. The flexibility of cables terminating in a consolidation point or MUTOA make changes in the layout of an open office very easy and cost-effective. Zone cabling is not only advantageous in an office environment, but it is almost mandatory in an intelligent building environment. Intelligent buildings will have so many more devices that can run on Ethernet as compared to a typical office. But getting to that consolidation point or service concentration point is not easy. so having extra cable at an accessible area is essential. The same principle applies to hospitals. Restricted areas, solid ceilings, medical equipment all make it difficult to run cable all the way back to the telecom room. Strategically placed consolidation points make moves, adds, and changes an economical and flexible solution. One of the main differences between a MUTOA and a consolidation point is how the cable reaches the end user device. When using a MUTOA, the box is accessible, affixed to something permanent, and cables are run directly to the device from the MUTOA using a work area cable. The work area cables are stranded and rules for derating are applied. Cable from consolidation points are solid and terminated at a telecommunications outlet at a wall or workstation, etc. Then a patch cord is used to connect to the device. Consolidation points are generally mounted in a ceiling space or underfloor and require accessibility. As with most things in the IT industry, standards evolve, and cabling standards are no different. When there is a requirement for change, the standards bodies and the manufacturers of network devices and network infrastructure collaborate to ensure that requirements are met that benefit end users. Devices that connect to a network are not always fixed, and in some cases are required to move. In Australia, the standards bodies recognize this, and changes were made to ASCA S009 2020 as it pertains to movable cabling. The major requirements are that the MUTOA or consolidation point are to be used, and the cable from that point to the outlet or device is to be flexible, which means stranded in composition. The most common usage for movable cabling that we see in Australia are in the case of sit-stand desks and pendants. Pendants are mostly found in hospital environments. In these two scenarios, a cable is typically terminated at an outlet which is fixed to the desk or at the bottom of the pendant with other outlets such as nurse call or oxygen, etc. These cables have the possibility of moving multiple times a day, and without the use of stranded cable, they would not be able to withstand the bends and twists that happen in these situations. Remember, derating formulae must be applied when using stranded cables and patch cords. From all of us at the CMON Company, we thank you for your attention and your support. For any information about our company, our product, or our warranties, please visit us at www.cmon.com or call your local CMON rep. Through education, we will continue connecting the world to a higher standard. Thank you.